In this lesson, I'm going to demonstrate how to do sorting using the quicksort algorithm. You notice we have an animation running on the screen. It's almost finished, so let's use it to describe how the quicksort algorithm works. We take our unsorted data, then we create a partition by breaking the data set into halves. Then we take each half and further break those up into sublists or subpartitions, and then sort those subpartitions when they get down to just 2 elements each. You notice how that works. Watch the shading as you see the small partitions. See how we get smaller right there? And by doing that recursively, we eventually end up with a completely sorted data set. Watch the animation again. Take half, start at the lower half, break it up into sublists, and then sort those smaller sublists so that all you're doing is exchanging elements if they need to be sorted. Same process for the upper half. Okay, so now let's see how to write the code for the quicksort algorithm. Our function is called quicksort. Its parameters are an array, the left value, which will be 0, and the right value, which will be the upper bound of the array. I and j will be the variables that we use for loop control, so we'll set those equal to the left and right values. We also need a temp variable for swapping. So once we've set up our variables, the first thing we do is create our pivot point. And we do that by finding the midpoint of the array by taking left plus right, divide that by 2. That will be the middle point of the array, and that's where we'll pivot. And then we'll sort each half of that. And here begins our loops for doing that. So we have a while loop, and then an inner while loop, which begins our left-hand side partition. And then a second loop for the right-hand side, or the higher values. And that's a j minus minus right there. Here's where we will make a swap. So we take array sub I, put it in temp, put array sub j's value in array sub I, take the temp value and put it in array sub j, increment I by 1, decrement j by 1, close off the if, close off the while. Then we check to see if we need to keep sorting, and if so, then we call the function again with new values. So that's to check to see if we need to sort the left side. Now we're going to do the right side, and that's it. So there's our quicksort function. I've already written a program to test the quicksort function. So we create an array of 100 elements. We randomly assign elements to that array, display the unsorted array, then display the sorted array. Let's add a couple of indels in here just to be on the safe side, or at least one after the display. That should be enough. So let's build and run the program. Okay, so take a look. Here's the unsorted array with values just in random order. And here's the sorted array, and if you'll check it, you'll see that it's sorted all the way through. Now just for fun, let's try it with 1,000 elements. Our display is going to be quite a bit messier, but we can also see the speed of how quick it executes. There we go. So here's our unsorted array. Here's 1,000 elements. And then here's our sorted array. Notice we have lots of values that repeat, but that's okay. They're still all in sorted order. I should also mention that quicksort is not what is considered a stable sorting algorithm. In other words, when we see these repeating values, all these ones, for example, there's no guarantee that this first one was the first number, that is 1, that the algorithm encountered in the data set. And that's what's meant by stable. By stable, that means that values that are not unique will be kept in the original order that they were found. And the quicksort algorithm, when implemented efficiently, is not considered a stable sorting algorithm. So there's an example of the quicksort algorithm for sorting data. Quicksort is certainly considered one of the most efficient and fastest sorting algorithms, and many times when you see a sort function that's in some sort of programming library, that sort was implemented as a quicksort. So that wraps up this chapter on algorithms, and we're ready to move on to the exercises for